All right, now that we have learned a little bit about how to measure intensity in speech or sound in general, we want to figure out how that relates to stress, or at least use it as a measure, a phonetic measure, an acoustic phonetic measure for determining when things are stressed or unstressed. Yeah, so to get there, though, we still have to work our way through a couple of other constructs, the first of which is called sonority, and the second of which is called a syllable, which is one you're probably familiar with already, but we need to think about it a little bit in terms of what we already know about how phonetics works, and phonology as well. So we'll get there eventually, but we still have a little ways to go. Another thing I want to touch upon is the fact that there are interesting facts about vowels and sounds in the world's languages, which we now can sort of quantify, knowing how to measure the intensity of some sound. In particular, it's been noted for some time now that some vowels are louder than others in speech. And I'll give you the data from a study that was done way back in the 60s that looked at the overall intensity of different vowels relative to ah. So ah was kind of the baseline for this particular study rather than like the quietest sound that you can hear. So ah's intensity with respect to itself is going to be 0 dB. It's the same, right? So, but these other vowels, it turns out, have lesser intensity than ah does. So A is 3.6 decibels quieter or less intense, and O is 7.2 decibels less intense, so on and so forth. E is almost 10 decibels less intense. U is 12 decibels less intense on average, I guess, as produced by various speakers in various conditions. Why is that? Can you think of a reason why ah's intensity might be different from these other vowels? And I'll let you think about it here for a little bit. Normally I ask it in class, this question in class, and it takes about a minute or two for people to kind of recognize what's going on, but it should be intuitive if you just kind of produce the vowels yourself. And say like ah or e, so on and so forth. I think you can even hear it the way I'm saying it. Ah versus e. The ah is going to sound a lot louder, even if I'm kind of targeting like the same overall level of intensity. And the reason is, maybe I'll turn to the side to produce these, but ah versus e, or especially oo, your mouth opens up more for an ah, right? So ah, a, e, you have a lowering of the jaw to produce the low vowel for ah, so your mouth is open more ah than it is for e. And the more open your mouth is, the more air is going to come out of your mouth when you're saying that vowel, and the more intense that vowel is going to be. It's pretty much that simple. And then there's a sort of another factor that gets involved here as well, which is that of lip rounding. So ah, a, e are all unrounded vowels, right? And so that intensity difference between those three is simply going to be dependent upon the extent to which your mouth is open, according to whether we have a low, mid, or high vowel. So the mid vowels should be a little bit more intense than the high vowels, and then the unrounded vowels should be a little bit more intense than the rounded vowels, because in addition to sort of closing your jaw a bit more for O and oo, you also round your lips for them as well, right? So the opening or the aperture of your mouth is going to be even smaller or tighter if you're rounding your lips, especially for an oo. There's barely enough space for any air to get out for an oo, so it's the quietest vowel, basically. And I think we actually talked about that or heard that a little bit when we were going over the cardinal vowels with Daniel Jones back a couple of weeks ago, right? An E or an oo is going to sound a little bit quieter than ah, just generally speaking, across the board, or ceteris paribus, as they like to say, if they want to sound pretentious. Anyways, another interesting fact about vowels is that some vowels are inherently longer than others. So I'll give you some data again from a study done in the 60s. We've known about this for some time. This is data from Swedish, which has both long and short vowels, and it also has rounded vowels in both front and back positions. So we have the high vowels, e, u, and oo, in long and short versions, and these are about 140 milliseconds long in the long version and 95 milliseconds long in the short version. The mid vowels, which include a, u, and o, are 155 milliseconds long in the long version, and again shorter in the shorter version, but they're a little bit longer than the high ones, right? And then there's low vowels, a, and ah, and these are even longer than the mid vowels. So we have another sort of continuum of length getting bigger as we go from the high to the low position for the vowels. Why is that the case? Yeah. I'm not sure how well my voice is working today, but you don't really need it to answer the question, right? You can maybe intuit already that the reason for this is the same reason as the one we cited for the intensity difference between different types of vowels, right? So you open up your mouth more for a low vowel, ah, and because you have to open up your mouth more, it takes longer for your jaw to go down, for your tongue to get into the appropriate position for producing that vowel. And so that sort of gestural complication, or necessity rather, is what can determine how long it takes you to produce that vowel. It takes you a little bit longer to get in the position for ah than for e, right? You don't have to move your jaw down or your tongue down as much for an e as for an ah or an ah. And of course, long vowels should be longer than short vowels. That's not controversial, but this is just another fact about phonetics, which has an influence on the acoustic characteristics of these particular vowels, even though we normally think of them as, the same if they're long or the same if they're short in terms of their length. There's another sort of low-level phonetic or acoustic phonetic effect you can get based on the sort of technicalities of how a vowel will be produced. And this has to do with frequency rather than length or intensity. And this is an example from the old mystery tone language exercise, so not the one that we did for class, but one using a different language altogether. And I no longer use this mystery tone language, not that there was anything wrong with the language itself, but I didn't have great recordings for it. I think, if I'm not mistaken, the name of the language was Amoy, and it was spoken in southeastern China somewhere. And I had a male speaker who was producing a high tone, a high level tone on both an E and an ah. So I'll play you the samples I had, which are not, again, super high, great recording quality, but here you go. Yeah, I'll do that again. A little bit louder. And so that's supposed to be the same tone. And you may be able to hear, and I think you can probably see that the specific or actual F0 value for the E is a little bit higher than the F0 value for the ah. And you can hear that too, right? So you might not perceive those as like the same tone if you're not a speaker of this language, because it sounds like there might be a minor sort of distinction there between the E tone and the ah tone. But they're supposed to be the same. So that's another reason I kind of set that old mystery tone language exercise aside, because it was a little more complicated than it needed to be. But sort of the more interesting question is, why is there that frequency difference? Why is the F0 different between E and ah, even if it's supposed to be for the same tone? So people, again, going back to the 60s, have observed that F0 is usually higher for high vowels than it is for low vowels. So we're getting another sort of high vowel versus low vowel distinction here, maybe a little bit in the opposite direction of what we've seen before, because we're getting higher values for the high vowels than we are for the low vowels. So if you just record F0's value across a variety of productions by a variety of speakers, you'll see that the average F0 value for E and U, high vowels like that, is about 180 hertz. For low vowels, though, it's closer to about 160 hertz, and the mid vowels are somewhere in between, right around 170 hertz. And I'm assuming this is averaged across both male and female speakers, because it's kind of, these numbers are kind of like halfway in between the average F0s we'd expect for male and female speakers altogether, right? Why is that? What's going on? I kind of jumped to the punchline there, but I'll take a drink of water to let you think about it. Because this one is not actually quite as simple as just like, well, you open your jaw more and therefore you get like more or less F0. Instead, the hypothesis, which people appeal to try to explain the idea that high vowels have inherently higher F0, is called the Tonguepole Hypothesis, or at least this is one predominant explanation for this. It's a little bit complicated, but I'll try to walk you through it. So kind of the idea here is that we're looking at some mid-sagittal diagrams of the larynx here, rather than the oral portion of the oral pharyngeal nasal tract, or the vocal tract altogether. So we're looking down here in these, I believe, MRI pictures. And you can see at the higher end of the spine, there's actually a little bit of a curve here, where rather than going straight up into your head, it kind of curves to go towards your back, right? And your larynx is right in that region, so it can kind of move up and down around this bend. And so normally, if you exert more tension on your vocal folds, you'll get higher F0, kind of tighten them or straighten them out. And then also, if you raise your jaw and your tongue to produce a more high vowel, it's going to raise up the entire larynx kind of around this bend. So that's what this diagram is supposed to be trying to show. That if you raise the larynx up around that bend, the vocal folds in here are going to stretch out a little bit and tighten up for that reason, and you'll get higher F0. The term I've used here is longitudinal tension. If you want to learn more about that, you can take my 441 class, but basically that means you're stretching out the vocal folds more, and that's how you get more or higher F0. So just by raising your tongue like that, you can get a higher pitch, and if you lower your tongue and jaw like that as well, you tend to get lower pitch. And I actually had a student a while back ago who did an honors thesis on creaky voice, which we've talked about a little bit. And she found something interesting, which is that if you have a lower vowels like you tend to get more creaky voice with low vowels like that, which is kind of like at the bottom end of your pitch range, right? Okay, I'm kind of dwelling on this a little bit too much, but I will give you the overall intrinsic summary of how vowels behave in terms of their acoustic phonetic features, or the quantifiable acoustic phonetic features that they have. So in terms of intensity, we normally expect low vowels to have more intensity and high vowels to have less as a function of jaw opening. And the same goes for duration, where low vowels have a longer duration and high vowels are shorter. But then for F0, high vowels tend to be higher for that, and low vowels tend to be lower in their F0 in terms of what's called intrinsic pitch. So people don't often appeal to like intrinsic intensity or intrinsic duration, and we'll talk about why in a second, but they do say intrinsic pitch for the fact that high vowels tend to have higher F0. I will say, though, the thing that's interesting about this is that all these factors, or phonetic measurables, I guess you could say, factor into perceived prominence and stress. So intensity, duration, and F0 will all feed into a sense of vowel or a syllable sounding more stressed. And the pattern is that more intensity sounds more like stress or more prominence. Longer duration will give you a sense of more stress as well. And then also higher F0 will sound like something is more stressed. And in fact, when we produce stressed syllables, we make them louder, we make them longer, and we make them higher F0 in general than unstressed syllables are. So it gets complicated, right? In general, you kind of look at this and say, well, low vowels should kind of sound like inherently more stressed than high vowels. And for these two features, that's the case. Whereas for the F0 parameter, you kind of get the sense that maybe high vowels sound more stressed than low vowels. So it's complicated, but the overall moral of the story is that there's sort of just inherent phonetic features or values for these particular vowels, which make them stand out more or less than other vowels in the neighborhood. So that leads me to this concept of sonority, which I was alluding to before at the beginning of this lecture. So loudness or intensity are highly context-dependent measures. They can vary wildly within from speaker to speaker, from room to room, or across speaking contexts. I think we all know that sometimes you, as an individual person, will speak more loudly than in other cases, like if you're yelling to get somebody's attention across the room, or if you're just like quietly whispering to, somebody you know right next to you in a movie theater or something. You speak with different amounts of loudness or intensity, right? And then there's some people specifically who just speak more loudly than others. I know when I speak in classrooms, I have to speak pretty loudly just to make sure I am able to capture everybody's attention and so that people in the back can hear me as well. And I'm unfortunately transferring that habit over to these lectures that I'm giving at my home, even though they might be too loud for this video. But, I'm not always like that. Some people are. Even in spite of that, and I guess I'll say on top of that with intensity and loudness, is that it does vary a lot, and it can make it a tricky sort of acoustic parameter to measure in terms of its usefulness when you're doing some sort of recording experiment in phonetics. So you might want to record somebody or a variety of people producing sounds that are maybe stressed or unstressed in the lab, but it can be hard to get a good read on how loud something is because it varies so much by speaker, and it also varies a lot by how far away the microphone is from a speaker's mouth or something like that. But all other things being equal, ceteris paribus, some speech sounds are simply going to be louder than others. So in the course in phonetics, they define this quantity called sonority as the sonority of a sound is its loudness relative to that of other sounds with the same length, stress, and pitch. So that's the all other things being equal. Part of it is this stuff at the tail end, but the sonority idea is just that there's sort of this abstract loudness that we perceive sounds to have, speech sounds to have, that is, and it's called sonority. And you can kind of think about that as like how much does it resonate? How sonorous is it if you want to? This is the scale that is given in the Course in Phonetics textbook from Peter Ladefoged and now Keith Johnson as well. But it shows you that on the sonority scale, we expect the low vowels to be the most sonorous things, like ah. It kind of sets the standard over here on the left-hand side. Then we move into sort of the mid vowels and then the high vowels. And then a rounded vowel like oo is going to be a little less sonorous than I, so on and so forth. Then we get into like liquids or lateral approximants, nasals, voiced fricatives, voiceless fricatives, voiced stops, and then finally voiceless stops at the tail end. And I've actually got a whole scale labeled out here in a different fashion to give you the actual kind of names of these groups of sounds to make it maybe a little bit easier to digest. So just keep this in mind. The kind of main phonetic basis for this distinction that we've talked about already is that between low vowels and high vowels. I showed you that low vowels kind of have two features in their favor for sonority, intensity and duration, whereas high vowels have that one other one, F0. So on balance, low vowels are going to sound or be more sonorous than high vowels. And then all the vowels will be more sonorous than things like glides or liquids, approximants, because your mouth is open a lot more for vowels than it is for consonants. And as we go down the scale, that's basically what's going on, is that the more closed your mouth is, the less sonorous the sound is going to be, because the intensity or loudness of the sound simply depends on like how open your mouth is when you're producing the sound. Okay, there are more technical ways to define this, but we'll stick with this for now. And normally I write this on the board, but I think in this case, I'm just going to go back and refer to it as I go through the next couple of slides. Excuse me. But this is sonority operationalized, I guess you could say, on a particular scale that we can use to try to interpret what's going on in phonology. So why this is relevant is this old idea, which goes back further than the 60s. It goes back to the 40s. And now that we're living in the 20s, I can see that someday we will, or I will probably live in the 40s again, hopefully. I'm not liking the 20s so much so far, but maybe the 40s will be better than the last 40s. We'll see. Anyways, back in 1943, Kenneth Pike, kind of the grandfather of structural linguistics, came up with this idea that syllables are organized around peaks in sonority. So this is called the sonority sequencing principle, or the SSP for short. And basically, the idea with a syllable is that it's going to have some sort of anchor or peak in the middle of it, which is going to be the most sonorous sound in that particular syllable. So to give you an example, we have the word bad in English, which has two voice stops on the edges of that syllable, and then it has this low vowel ah in the middle, right? So the voice stops will have relatively low sonority, and the low vowel will have relatively high sonority in the middle. And we have this nice little pattern, kind of looks like a triangle, where we have the sonority profile rising up to the middle of the syllable and then going back down. This is a clearly well-formed syllable in English. It's uncontroversial that this is just one syllable in English, bad, and it has this nice clear peak in the middle based on the sonority of the low vowel. We can kind of fill in those gaps on either side as well with kind of medium sonority segments like L and N. So L is a lateral approximant or a liquid, and N is nasal, right? So if we go back to our scale, we got an L here, we got an N here. Here are our voice stops at the very bottom of the scale, and we have a low vowel in our syllabic peak. So bland is going to be a perfectly fine individual syllable as well, right? The idea is that, going back to Kenneth Pike, syllables are organized around these peaks. So there's our sonority peak. That's going to form what's called the nucleus of the syllable, which hopefully is a term you've heard before, but if you haven't, why not learn it now? And then what the other parts of the syllable are determined by whether they come before the nucleus of the syllable or after the nucleus of the syllable. So the stuff that comes before the nucleus is called the onset. Yeah, in this particular case, it's the blah of bland, so the B and the L, rising up to this syllabic peak in the middle. The sounds on the end of the syllable after the sonority peak are the coda of the syllable. So in this case, that would be the N and the D. And then you can actually combine these two together, the peak or the nucleus with the coda, and form something called the rhyme, which is pretty straightforward to understand because this is the part of the syllable that rhymes with other syllables, right? So bland rhymes with hand or canned or panned or land or whatever. They all have the same rhyme, and that's why. They just have different onsets. I will be remiss to myself if I don't tell you this goofy family story that when my sister was like in first grade, my sister is named Lisa, and she went to first grade and they were teaching kids how to rhyme at that time, and she made the mistake of thinking that rhyming was more like alliteration, that the thing that matches in a rhyme is the onset of a syllable rather than the coda. So they asked somebody, I guess the game was they went around to each kid and then they asked the kid to say their name and then something that rhymed with their name. And then my sister said Lisa Love, because they both start with L, but that does not rhyme, as we know. And in fact, it's hard to think of what would rhyme with Lisa, so maybe she was just being productively creative there. But this is what rhymes, right? The nucleus and the coda. Wow, my name is Steve. What rhymes with Steve? Leave. Okay, maybe it's not that hard. Anyways, some basic principles according to the sonority sequencing principle. The idea is that onsets must rise in sonority towards the syllable peak. So if we go back to our scale, or even our example, we want to have a high point of sonority in the middle of the syllable, and we want to have the onset rising in sonority as it goes up in this direction. So here we have a voice stop followed by a liquid. So we're increasing in sonority. I've got some other examples here, like stop, liquid, like play, quick, or fricative, followed by an approximant of some sort, like fling or thwack. You could also have an S in particular. S does a lot of work in English phonology, but that could be followed by a liquid, nasal, or glide, like slide, snow, sweet, so on and so forth. If you follow this principle, if you adhere to this rule in phonology, what onset clusters should be ruled out? What sort of sequences should we never see in English phonology, at least, if we're actually obeying this principle? I'll let you think about that for a second and let you know that kind of the easiest example to think of is what you would get when you just flip the order of these things, right? So we have play, and what we would not expect to see is like, let me turn on my IPA font. We'd not expect to see something like, we'll pay as like an individual syllable, right? Or rather than quick, we wouldn't get wookik as like an individual syllable, right? That just doesn't happen. But it turns out there are some English examples where this doesn't work. And normally the joke I tell in class is like, oh yeah, we never get, you never get, you can get a stop followed by a fricative. Like, actually, it's a little bit tricky to think of that. But you shouldn't be able to get examples like Steve, right? So this is a fricative followed by a stop. So a fricative has a higher sonority than a stop, especially a voiceless stop like T. So Steve should be bad. And in fact, we never get that word or syllable in English, right? There's no word Steve, right? So, okay, maybe not. Maybe there is a name called Steve, and maybe it is violating the sonority sequencing principle. But stopping to think about it, it's hard to think of flipping what you would get when you flip those two sequences or two types of sound around that would actually work. So I can't think off the top of my head if we have like a deceive, anything like that in English, which should be okay according to the sonority sequencing principle. We have, words like cheese, which have this affricate here at the beginning. And maybe we're able to get around that, if I can remember how to do that, because that's an affricate, or maybe we can just do that anyways because it follows the rule. But we're having a little bit of difficulty here in that things that are supposedly ruled out by the Sonority sequencing principle are still okay. We can get kind of an S in this particular context, even though I don't think you can get other sounds there. Like I don't think you can get thief, right? Not to make any jokes about lisps, but just that sequence itself is ruled out. We don't, at least officially have any sequences like that in the English language. So to a certain extent, this works. We can also think about it with respect to the other end of the syllable. So after we get through the syllable peak, we're supposed to have a drop in sonority down to the tail end of the syllable. So we should see sequences like this, like where we have these middle sonority things leading to things like fricatives and stops, like a nasal or a liquid going to a fricative in like tenth, or a stop in hand, or bland. And we should also see the same thing for a liquid in this kind of middle position for words like help, helm, or heart. So the L has more sonority than a nasal here, so on and so forth. We should also see like fricatives and stops, like in test, a fricative has more sonority than the stop at the tail end of it. But what's supposedly ruled out by this would be a sequence like tests, or even something a little simpler than that, like hits, because here we have, again, a fricative after a stop. And that's not supposed to happen. So we're going back up in the sonority profile when we get these stop fricative sequences in the coda. So there are counterexamples to that as well. And it might be harder to find cases where you get violations that are not involving S, but I can think of a word like width, like that, which is, I'm pretty sure, just one syllable. And we have a voice stop followed by a voiceless fricative. So that's, again, violating the sonority sequencing principle. I don't want to focus too much on the exceptions to this rule because the rule is generally okay, but it's just not perfect, right? It works more than 90% of the time. And usually the thing that violates it is the segment S. So S is kind of funny in English, at least. And I know some phonologists kind of try to fix that by saying, well, like, S is extra metrical. It kind of like is just in its own little world in the sort of syllabic sequence of a word. And it doesn't really count. And maybe that's how we can fix the theory. But maybe we can just say, this is not exactly how syllables are organized. But then the question rises like, how exactly are syllables organized in English? So the sonority sequencing principle doesn't always work. It's still useful for you to know because you'll encounter it out there. But we want to know, like, how are we going to be able to define a syllable in language? Phoneticians, thinking on sort of a less abstract level, since Kenneth Pike, have suggested that maybe a syllable involves chest pulses. So like each time you produce a syllable, you kind of like squeeze your chest a little bit and a little more air comes out of your mouth. It turns out that works better for like stressed syllables than for unstressed syllables. For stressed syllables, there's usually a little bit more air that comes out, but for unstressed syllables, they can all kind of just like glom along on the same like stream of air without any extra air coming out. So that doesn't totally work either. Peter Ladefoged, before he wrote the Course in Phonetics textbook, or at least a long time ago, investigated this and looked at what chest muscles do when you're producing different syllables, and found that we don't even have sort of like little squeezes or contractions of the muscles when we have each syllable in the stream of speech. Again, you get that more for individual stressed syllables and not for every single syllable. So you can't really define syllables at that low level, sort of articulatory level, in terms of what's going on with like the muscles or the whole structure of your breathing apparatus as you produce speech. So are there any better ideas? At this point, I'm welcome to entertain any from you, if you might have some. You might save the world of phonetics and phonology a lot of trouble if you can figure this out. But that's actually one question I'm not going to answer. And I'll let you puzzle over it by looking at this set of data. So this is a fun little example, which I often use in my 201 class, perhaps much to that class's dismay. But what I want to look at here is these 6 words, all of which are spelled with an initial A, and all of which have stress on the second syllable. So whatever is going on in the first syllable, it's unstressed. And so normally what I do is just kind of walk everybody through a transcription of these 6 words in class, and then I ask, when is the first vowel schwa? So we don't have that luxury at the moment, so I'm just going to kind of walk through what I think the transcriptions of these guys are, and then I'll put little syllable boundaries, and maybe we can figure out what's going on. So Atlantic, normally I will produce that with an E at the beginning, and then something like this at the tail end, Atlantic. Maybe maybe this is a glottal stop, something like that, but I'll stick with a T for now, Atlantic. Like an unreleased T, basically. Atrocious, in this case, I can't remember how I did. There we go. Got to remember all my codes. I should have practiced before I did that. Atrocious, okay, yeah, it's not an S there. Something like that. Atrocious, maybe you have a different vowel here at the tail end in the unstressed syllable, but it's a schwa at the beginning, right? How about America? Something like this. Yeah, so that's another schwa at the beginning. Hopefully you agree. Arcade, I don't think we have a schwa there for most speakers. It's more like arcade, like that. Astronomy, might have to make some space for this. It's not capitalized. I get a schwa there too, right? Astronomy. Oops. My E key doesn't work for some reason. It's extremely helpful. There's actually a book that was written without any E's in it. It's called Gatsby, and apparently it's extremely boring. But it's a major feat of nonsense. I don't want to do that today. I just want to focus on whether there's a schwa in the first syllable of these forms, or whether there's some other different kind of vowel. So we actually get 3 forms that have schwa in the beginning: atrocious, America, and astronomy. And hopefully you can hear that there is stress on the second syllable of each one of these: Atlantic, atrocious, America, arcade, astronomy, and arthritic. Okay, so what determines if there's a schwa on the first syllable or something else, a different vowel? And then one way you can maybe tease this out is to answer this question as well. Is there a difference between the T in atrocious and the T in Atlantic? Actually, I kind of gave that away a little bit because this one is an unreleased stop, right? I talked about that. Atlantic, you hardly hear that one at all. And this atrocious, it might be an aspirated T for you, like that, or it might even, in fact, be just atrocious. I don't think I say it that way. Atrocious. And if I'm focusing on it, I'm not going to do very well. But it might be a atrocious. I came up with a tongue twister on the fly. Yay. If you can record yourself saying that one 3 times in a row fast with no mistakes, I might think about giving you a bonus point. But either way, this is a different T than this T. And then this is a different vowel from this vowel. So hopefully you see this by now. I've kind of dawdled here a little bit, hoping to give you time enough to figure out the pattern. But basically, the important part of this is how we syllabify these words. So with each of the forms that only have a schwa at the beginning, the schwa is all by itself in that initial syllable. So I'm going to use the IPA notation here, which is just to put a dot in between the individual syllables. And I'm only going to put this after the first syllable just to keep it relatively simple. We probably get into a few debates about the rest. But these other initial syllables have coded consonants, like the et in Atlantic, or R in arcade, or R in arthritic. And if there is a coded consonant, then we don't have a schwa at the beginning. why are we getting, oops, wrong one. Yep, I am blanking on how to create a stress symbol, which is relevant for this lecture. So I'm going to look this up real quick, hopefully without embarrassing myself too much. But why is that happening? Why are some of those, there we go. Why are some of those yielding syllables with codas in them and others are not? So we have this, and it turns out it depends on the way English syllabifies. So basically, if you have a syllabic or a stressed syllable, kind of the vowel of that stressed syllable wants to grab as much of an onset as it can get. And we see that kind of nicely in astronomy. So this is violating our sonority sequencing principle, but stra is an okay onset in English, right? We get it in a word like street or stray or whatever. And it can work for strawn in astronomy too. Tra in atrocious, that is also an acceptable onset. What is not an acceptable onset would be tla, like in Atlantic, something like that. That's why we don't pronounce it as Atlantic, because we don't have any other words in English that are tla. And I'm not counting the name of that language, Tlingit, which maybe you've never heard of, maybe you have, but either way, this is kind of the only exception to that rule where if you're comfortable saying this as Tlingit, you will. But a lot of cases, apparently even when you say it like that, people hear it as Klingit. Yeah, it has nothing to do with Klingon, I'll tell you that much. Anyways, another kind of sequence, so the I in arthritic wants to grab as much of an onset as it can, moving towards the front of the word, but it can't grab like arthritic, right? It's not arthritic, it's arthritic. So this consonant winds up being in the coda of the initial syllable, even though it's unstressed. And if that is the case, then that vowel is not a schwa. If there's no coda at all, then we get a schwa, like in America, or atrocious, or astronomy. And I'm not going to say atrocious again, because I don't think I can. Anyways, this is a long roundabout story to explain how this little example works, but the reason I'm referring to it is because we could not explain this at all if we didn't have recourse to talking about syllables or syllabic structure in these words. We need to know whether this consonant is in the coda of this initial syllable or not. So in order for that to be possible, we need to assume that there are syllables that each sort of segment sort of winds up in one syllable or the other as we produce the word. That is hopefully uncontroversial for you, but it's kind of hard to show explicitly in phonology or phonetics because you can't really pin down one sort of measurable thing, which will say, oh, that means that this sound is in this syllable or another, right? It's something you kind of have to infer as a pattern, or you have to infer from the patterns you see in how sounds get organized in language. So that's how Latifoga defines syllables, ultimately, saying that they are necessary units in the organization and production of utterances. It's just sort of the way people structure their speech production, and they can't do it without that sort of timing through language. Although I will say, we don't really talk about this much in this class, but there are certain languages which are syllable timed, like English, and then there's others, there are certain languages which are syllable timed and certain languages which are stress timed, in which you have sort of equal amounts of time given to syllables and to different syllables in the syllable time languages and different amounts of time given to stress syllables in the stress time languages. I'm not going to get into that. So you can organize, but I just will say you can organize production along the terms of stress as well. For now, I just want to focus on what syllables are and why we need them. But the construct of a syllable can account for a variety of interesting phonological patterns all across the world's languages. So you can get vowel reduction in unstressed syllables in English, like we kind of see in the previous example. When we have unstressed syllables at the beginning of a word without codas in them, we get just the schwa. We can't explain that without being able to appeal to syllables. We also see patterns like fricatives and stops, devoicing at the ends of syllables in German and Russian and many other languages, so on and so forth. We also get place contrast disappearing in coda position. I cite this in Japanese, but it also occurs in many other languages around the world. Excuse me a sec. these coda effects would not happen unless there was a coda, basically, in the syllables in these languages. In an onset position, we get voiceless stops in, say, languages like English or German that are aspirated in that onset position for stressed syllables. We can't explain that unless we assume there is such a thing as an onset of a syllable. Okay, again, I don't think it'll be uncontroversial for you to think that there are syllables in language, but it's just kind of hard to prove, and that's why I'm walking through this sort of evidence for the idea. What we should focus on before we finish is how does this relate to stress, which is kind of the main goal of this overall pair of lectures that I've been giving you these last 2 times. So stress is a suprasegmental property that applies to whole syllables. And that's where it kind of gets interesting. So stressed syllables will usually be higher in pitch than other syllables that are not stressed, especially the ones in their neighborhood. Stressed syllables will usually be longer than unstressed syllables. Stressed syllables should be louder than unstressed syllables, or more intense if you prefer to measure it in acoustic phonetic terms. And then there's also a more kind of fudgy quality, which you can basically refer to as quality, in that stressed syllables reflect more phonetic effort than unstressed syllables. And I'll give you a couple of examples of that. But overall, when you stress a syllable, you are kind of putting more effort into it. You're making the sounds more distinct, and that effort also translates into these different acoustic parameters too, in terms of pitch, length, and intensity. The combination of all these factors from a listener's point of view gives stressed syllables more prominence than unstressed syllables. So if a syllable is higher in pitch and longer and louder, you're going to hear that as stressed, as it's going to be jumping out more prominently from the other syllables in its neighborhood to you as a perceiver. Okay, I have some basic phonetic data from a couple of stress contrasts in English. I think I've played a few of these examples before, but we know you can get noun versions of the same sequence of segments in a word, and you can get verb versions of those sequence of segments. And the only difference is between the two basically is where the stress falls. So in the noun version, we get stress on the first syllable. In the verb version, we get stress on the second syllable, and it sounds like this.
Insult. Insult.
Or that. And you can hear the stress contrast because you know what these words mean, I presume.
Insult. Insult.
And we can see if we look at pitch tracks for these guys, and I've just kind of excised out the F0 tracings here alone, but we get a higher pitch on the first syllable of the noun form and a lower pitch on the second. And then we get a slightly higher pitch on the second syllable of the verb form than we get on the first. It's a little tricky, though we don't get as big of a distinction here when stress is on the second syllable. And that's because pitch will tend to drift downwards from the beginning of an utterance to the end of an utterance. So we tend to get higher pitch or a wider range of pitches at the beginning here, like in the first syllable of insult, and then it drops down a lot by the time you get to an end. So that decrease or that drop in F0 leads to this stress-based increase in F0 not being as high as it might otherwise be, but otherwise I think you can still see that F0 is going up. And so that's the one-way pitch signal stress. And I've labeled this as pitch, but technically it's F0, but I'm using them interchangeably for now. Intensity changes as well, and basically the same way. So here's the noun version of this word.
Contrast. Contrast.
So we have stress on the first syllable here.
Contrast.
And this is an intensity trace. So this is basically showing you, similar to a pitch track, it's showing you intensity in dB as it changes over time for this utterance. And we see this big jump in intensity for the first syllable of contrast, the con part of it.
Contrast.
And then intensity goes down here in the second syllable. But for the verb version,
contrast,
we see that jump in intensity here in the middle when we get to this a version of trast. Yeah, so hopefully that's obvious, but it can be a little more complicated than that from a listener's perspective. So the perception of stress, it turns out, is highly correlated with the area under the intensity curve. And we're not going to do calculations for that. It's not like we're studying calculus or anything for this class. Thank goodness. But basically, you can kind of imagine this like geometrically, maybe like there's a lot more space under here than overall under here, or there's a lot more space under here than there is in the first syllable. So this area under the intensity curve is going to depend not only on raw intensity, right? Like there's more of a peak of intensity here, so we get more area underneath that curve, but it also depends on duration. So if we get a longer syllable, that will give us more area under that syllable in the intensity curve than otherwise. So both intensity and duration are kind of factoring in together here. You get greater length or duration in a stressed syllable than you get in an unstressed syllable. And again, unfortunately, that gets complicated a little bit because when you get to the end of an utterance, you tend to slow down as well as like lower your voice in terms of its pitch. So oftentimes syllables at the end of an utterance, even if they're unstressed, can seem like they're taking longer. Your mind somehow is able to take all these factors into consideration and hear stress usually the right way when it perceives a contrast like this.
Contrast. Contrast.
And I did not mean to make a pun there, although maybe I did. Anyways, the last factor here is phonetic effort, which is basically that sounds are going to sound more clear when they're produced in a stressed syllable. Because you're putting more effort into them, you're kind of getting closer to the targets you initially intend to produce when you're producing that sound. Or you can just overall produce sounds in those contexts with sort of more distinctive qualities than they would have in an unstressed syllable. So voiceless stops, like I said before, are going to be aspirated more at the onset of stressed syllables in English. Another example I mentioned before is that vowels are often reduced to schwa in unstressed syllables in English. So you can kind of think of like the effort you put into producing a vowel as how much you kind of push it to like the extremes of the vowel space. Schwa is right in the middle of the vowel space, so that takes basically like no effort, like but then if you push your tongue around, you get to like e or ah or oo, like in Daniel Jones land. So since that takes more effort, they become more distinct in those like perimeter spaces of the vowel space. There's less co-articulation across syllable boundaries in stressed syllables too, which is kind of neat. And I can give you some data about this from an X-ray microbeam study, which was done by a former colleague of mine for his doctoral dissertation in the 90s. And again, this uses that methodology that we looked at in the demo, the online demo, where they were placing little pellets on speakers' tongues and jaws and so on and so forth, and then having them say particular sentences like, I said, put the toast on the table, not the napkins. And then they had this X-ray microbeam kind of zooming past or back and forth along their faces or through their heads, basically, as they were saying these things. And then the deflection of the X-ray microbeam by those pellets enabled some sort of amazing apparatus to determine where exactly the pellets were at any point in time when they were saying these utterances. Don't need to worry about that so much, as we do need to kind of think a little bit about what this study was looking at. So I'm giving you examples from two different utterances here. So I said put the toast on the table, not the napkins. So there's prominence here or more stress on toast. And in the second utterance, they had speakers say, I said put the toast on the table, don't throw it. So more prominence on put in this case. And what this study was looking at explicitly was what happens between the T of put and the of the eth of the. So this is supposed to be a alveolar stop, and this is supposed to be an interdental fricative. And it's the same in both cases, except you're putting more emphasis or stress on put here. So what happens to that T? And it turns out it becomes more distinct when you do that. So there's more basically of a clear break between those two words articulatorily. So this dotted line is the trace of the little pellet that was on the tip of this speaker's tongue, which again probably wasn't that much fun to like have on your tongue when you're doing this sort of experiment, but it worked out. So this speaker says then T here, and then moves over here to an interdental position for the. So there's kind of a clear distinction between the alveolar and interdental places of articulation when you stress that put. If you don't stress it, if you say I said put the toast on the table, then it becomes kind of more of a merged consonant. So this is the and then it goes to somewhere around here for this like the some sort of combination of a T and a interdental the, and then it goes back to the rest of the utterance after that. So your tongue kind of winds up splitting the difference sort of when it's not stressed, and it makes the difference clear when it is stressed. So stress affects phonetic quality. It sort of improves or enhances that quality when you're trying to stress a syllable. I'm not going to say anything further about that. I'm going to mention, though, briefly before I end this lecture, that English has both primary and secondary stress. And I don't want to say a whole lot about it because you can kind of look at it in a couple of different ways. But if you're interested in transcribing it, the notation that is used in the IPA is that this stress marker above the line is there for primary stress, and this stress marker, a vertical line at the bottom of the text line, is there for secondary stress. So in a word like exploitation, we get sort of varying levels of stress or prominence, and we can kind of work our way up the scale here and say that, well, if there's at least a vowel in your syllable, like or oi or a or a schwa here in shun, then that's sort of the most basic level of syllabic prominence. If you go above that, then you get a full vowel, which may or may not be stressed. So like the sploy, the oi, and exploitation. In most varieties of English, you can't reduce that to schwa, even if it's unstressed. So you normally would say exploitation rather than exploitation, right? But it's not stressed. So we do get stress on two syllables, we do get stress on two syllables, the ek and the te. But there's a bit of a stress difference there because so we have sort of more stress on the last stress syllable, exploitation, which is due to what is often called a nuclear accent or pitch accent in general, which kind of forces us to stress that last syllable a bit more. And that will sound a little bit more prominent for that reason than the initial stress and exploitation. Okay, so there's two ways to think about this. If you want to transcribe it in terms of the secondary versus primary analysis, then you can use this notation. I'm not going to get picky about that in class. If you hear a stress syllable, you can just use this primary stress symbol to transcribe it. That's fine. But part of what gets involved here is that there are sort of a level of prominence riding on top of stress as well that we get from conversational context. And that's really quite complicated, and we address that more in 441. If you want to go on and take that class, we figure it all out over a course of like 2 or 3 weeks. And it's a lot of fun, at least for me. Anyways, I'm done for this for now, but mainly the moral of the story for stress is that stress syllables are going to be longer, louder, higher in F0, and they're going to have sort of enhanced phonetic quality. And that is all going to be relative to other syllables in their neighborhood. And those features also apply to every sort of segment in the syllable, not just the vowel in the middle. And I will say as well, like exploitation, this N here in shun could potentially be a syllabic N. And just so you know, or make sure you think about this, when you do get a syllabic consonant, it just is something that fits into this peak of the syllable here, right? So we could have, I got to change this and remember on the fly how to do this. But something like that. Yeah. So bird would look like this. The would be the syllabic peak rather than bad. And that's how syllabic consonants work according to this theory. Okay, I'm done. We'll talk about something new next time. We'll get into acoustic phonetics at a more complex level when we talk about harmonics. So I'm looking forward to that, and I hope to see you there.